All right, we have a situation here. This is the way the society is going to work. Every family is going to have a child until they have a boy, and then they're going to quit. How's our society going to look? Are we going to have more boys than girls? Are we going to have more girls than boys? Or is it going to be about the same? Who wants to take one of them and argue? Reese?
It's going to be about the same because
Why?
there's going to be some families that have like 10 girls and then they have a boy and they're done. Or there's going to be some families that just have a boy. And
Well, just going to be about what percentage of families are just going to have a boy?
it could be probably about 50.
About 50%, right? So 50% of the families are going to have a boy. You said some families are going to have a lot more girls, but you think it's going to about even out. That's your guess. Yeah, I know what you got. You got an opinion. What do you got?
Yeah, okay, so there's going to be more boys than girls
Why?
because you're stopping with boys. So
Okay.
if you could keep going forever, then it would be the same amount. But you get to the point where, at the point where you're having your 7th child, there's less than a 1% chance that you even get to that
So the
point.
chances of having 8 girls is pretty darn slim.
Right.
Right? I mean, the chances of that happening, I mean, you could take that situation, well, if somebody has 8 girls, but the chances of that happening are pretty slim. You're saying that they're so slim that those families that have the boys will over, in the long run, there'll be many more boys than girls. Okay. Who wants to take the last one? More girls than boys.
No, I was going to say that I had a reason for a family like that.
No, I want more girls than boys. I already got that reason. Anybody want to take more girls than boys? A lot more girls than boys. Well, I'll take it. Come on, some families can have 10 girls. Right? I mean, you got 10 girls and 1 boy. I mean, that's going to greatly outnumber. In the long run, we're going to end up with more girls than boys. The right answer is C. It's going to come out about the same. Okay. Now, question. Can we do this experiment? Can we do this experiment in real life?
No.
No, come on. Now, we can't make a whole society of people do this, or even a sample of people do this. Okay, it's unethical in a million different ways. So how can we figure this out? How can we do it? Well, that's what we're going to be talking about today. We're going to run a simulation. We're going to have babies in Table B. Table B is going to have babies for us, and we're going to be able to do this using Table B and hopefully do the simulation with replication a lot of times, and we're going to be able to figure out roughly which one of those is right using Table B. Now, here's the deal. I'd say for the last 4 years, I've been guaranteeing that there's going to be a simulation problem on May 10th. I mean, I think 1 year I put my reputation on it, 1 year I put my life on it, 1 year I put my kid's life on it, and it never has happened. Okay, we haven't had, I mean, there was a bunch of them, and we haven't had one now for like 7 years. I guarantee this year, one of your free response questions is going to be to do a simulation. I get it's sure.
What do you got? What do you
Everything. I mean, it's going to happen. So my point is, this year we're going to be the greatest simulation class of all time. Okay, we're going to dominate the rest of the nation because we're going to be able to do simulation better than anybody else. Okay, so please spend the time and effort, know how to do this. It'll pay off May 10th. You have my word on it. All right, so here's what we're going to do. We're going to run a simulation, and we're going to make Table B into having kids. Okay, random digits into having kids. So this is going to be like center shape spread outliers. Remember, you had to write the word, you had to talk about them. Okay, this is going to be like what we've just been doing: randomization, replication, control. You're going to write the word, you're going to talk about it. When we run a simulation, these are the things that we're going to do. Okay, to show the reader that we've taken care of all situations, and we're going to be able to run the simulation. All right, so the first thing that we need to do is how can we assign digits to represent having children? So how can we use Table B to simulate having a child? Now here's what I always want. Now, this is just like the randomization thing you've been doing. I want you to tell me how many digits at a time are you looking at this week. It's the same concept, okay? I think you had your hand up first.
So 1 digit?
I think you're right. We'll look at 1 digit at a time. If I'm writing it, you're writing it. Jason, you with me, right? Yeah. Okay, so what are we going to do when we look at that 1 digit? What are we looking for?
You're looking for a 0 or a 1. You do 2 numbers.
Okay, you know what? Okay, I hear what you're saying. Zero's gonna be a boy, one's gonna be a girl, but we're gonna have a whole bunch to ignore. There's a way we
odds and
can.
evens?
Okay, good. That works good. So odds are gonna be what?
Boys.
Sure.
Makes sense.
And evens, girls. All right, now we got to take care of our situations here. Repeats and numbers outside the range. Okay, so what are you going to do with a repeat? So repeats don't count.
No, they would. Because
Yeah, in this case, if I get a 2, that means I got a girl. If I want to be 50-50 every time, right? So if I get a 2 again, that means another girl. So in this case, repeats are okay. Up until now, we've always been ignoring them because those are the types of problems we're doing. But in this situation, every new child's a 50-50 chance. I don't want to not have that number in there. Yeah.
So even if you get a repeat of an odd, because
That just means you had two. You've had two. Well, it means you had a boy, and then the next family you're looking at, those same numbers work. Now, remember, the odds are, you should have 5 of each, right? So 1, 3, 5, 7, 9. Those are the odd numbers. And then 2, 4, 6, 8, 0. Okay, 0 is one of the digits you might get, and that's going to obviously count as an even.
And there's no numbers outside the
And there's no numbers outside the range, so we don't have to worry about it. Okay, so the first thing is somehow we have to assign digits for whatever that particular situation is. All right, the next thing is the stopping rule. The stopping rule means is how far are we going to go into these digits until we stop, until we've completed one repetition. In this particular problem, one repetition is one family. Okay? And what I hope to look at is a whole bunch of different families to see how it works out with everybody. So what's going to be the stopping rule in this particular problem? So we'll stop after what?
after you get to an odd.
Okay, so I'll say it 2 different ways. We'll stop once we have a boy, and then I'll put in parentheses. You can say go till you get an odd, which means a boy, and you say it either way you want. But you're saying, okay, I know I need to go until I get a boy. It's basic. We're using numbers to do exactly this. That's what I want you to keep in mind. Whatever their situation they're describing, that's exactly how we're going to do this on the numbers chart. All right, the next thing now. You need to show me all the numbers for one repetition. Okay, so, I don't know, let's start, we've been starting on the same place. So go to table B and just start someplace for me. And then we'll just go from there. I don't want to use 1, 9, and again, that's just boring.
What do we do?
We're going to use James just to start someplace at random, and let's go through it. So right here, we're going to write down the numbers and say what we've got for one family, one repetition. So what? Give me a number.
135,
So I-
9, 135, and 6.
Wait.
Yeah.
Give me one digit.
Okay.
What do you got?
6.
6. All right, now what is 6?
Girl.
6 is a girl. Okay? So, all right, give me another one. We don't stop yet, right? By our stopping rule, we're not done yet, so keep going.
6.
We got another 6. So we got another girl. Okay?
And then 9.
And 9, we got a boy, and we stop. Okay, so for this particular repetition, what we got 2 girls and 1 boy. All right, now here's the hardest part of doing a simulation, in my opinion. Now what we want to do is we want to create some sort of a scoreboard. And we want to create a scoreboard. This is what I need you guys to remember. You want to create a scoreboard that when I'm done doing many families, many families, I can just look at my scoreboard, do a little calculation, and then write up my conclusion based on my simulation. And it changes, but you got to just focus on what are we trying to answer. Our final answer in this one is I want, what percent of boys and what percent of girls do we have? And that's what we're trying to look at here. So what do you want to put as your scoreboard? We're going to, put a tally mark here, but what makes sense in our scoreboard for this particular problem? And it changes from problem to problem.
Boys and girls.
Yeah, how many boys and girls we got? I agree. We're just going to keep track of how many boys and girls we get. So we just did one repetition, right? We got, 2 girls and 1 boy? All right, from this point on, I don't need to see these anymore. So you're just going to keep going through the numbers, and we're going to be just putting the numbers on our scoreboard. So do the next one. Keep going with your numbers there. Give me the next one. So I get a
2.
A 2. That's a boy, right? That's an odd? No. Boy. What'd you get, 2?
Yeah, I said 2.
2's even, right?
Yeah.
So I got a girl,
Good job.
and then I got
5.
5 and an odd. So the second time, on the second repetition, I got 1 of each, right? So I can just put those down. 1 of each. Yeah.
Do you want us to separate like by family?
You could. I mean, I've seen some like do 30 things here. But bottom line is, I just want to know how many of each I'm going to have when I'm done. So I won't require that. If you wanted to do that, that would be fine. Okay. I think tonight, instead of doing it on one of the problems you're going to do, one of the 50, I'm still trying to decide how many we're doing. But they're only going to have you do this 5 times, 5 repetitions. So in that kind of an example, maybe you would show each repetition. But if I'm asking you to do this 30 or 50 or 5,000 times, you wouldn't have to worry about that.
So
Okay.
it just kind of depends on.
Yeah, so let's do our third repetition. What do you got here now?
5.
5 is, boy, we're done, right?
Yep.
Okay. Go do this 30 times. Go. We've done it 3 times. We've done it 3 times. 30 is the minimum I would like to do it. I'd like to do it 3,000 times, but let's do it 30 and fill in your scoreboard. Now, I guess we'd all would kind of have similar, like different answers depending on where you're starting.
What line did you start?
Just start on your own. I don't care. Get your own. You all have something different, but we'll see what happens. Anybody done yet? When you get 30 done, somebody give me your final totals here. Okay, what do you got? How many boys do you got?
18.
No! Now I asked, this is the 3rd time in a row this has happened. I want 30 repetitions. Based on this problem, how many boys am I going to have to end up with?
30.
I didn't say 30 total children, did I? I want 30 repetitions. That means there's going to be 30 families, right? Which means there has to end up with 30. Understand what a repetition is, okay? A repetition here is the total number of children. It's each family having children is 1 repetition, and I wanted 30 of those. So when you get done in this particular problem, if I ask you to do it 30 times, you're going to have 30 boys, right? So did anybody get to 30 boys yet? What do you got? 30 boys and how many girls?
25.
25. Wow. Making Zane look right. I don't like that. What'd you get?
30 boys, 26 girls.
6 girls. Anybody get something different? 30 boys.
32 girls.
32 girls. Okay, so let's just stay with this for now, but you can see how it can be a little bit variable. So now in the scoreboard, okay, so you have these mods, you get, so 55. So we'll do the calculations now that will help us to answer the question. Trying to figure out the percentage of boys and girls. So the percentage of boys here would be 30 over 55. So we got a percentage there for me. Throw that in your calculator.
54.5.
Okay, so about 55% boys, and then the 25 over 55.
40. 45.
About 45% girls. Okay, and so now at this point, we would then write up our conclusion. And the conclusion would be, based on this simulation, our prediction is there'll be 55% boys and 45% girls. So based on that simulation, you're looking pretty good, right? You know, although I did say a lot more boys and a lot more girls, but based on this simulation, you know, we could reach a conclusion that would say you were right. Okay? Remember replication now. We'd like to do it on as many subjects as we can. It fits here too. If we'd have done this 50 times or 500 times, the percentages you would get here would be actually closer to what the actual value is. But we saw one time we had 32 girls and 30 boys, so you can see that there's some chance variation when you only do it 30 times. But we've run a simulation. So at least now we kind of have an idea, don't we? And if I was really wanting to know what this percentage was, I would do it more than 30 times. The more you do it, the closer it's going to get to whatever that right answer is. Yeah?
But so if we get that on May 10th, you just recommend we do 30 times? And then we should
Yeah, so tonight, you have 2 or 200 problems I'm trying to figure out. On one of the problems, it's going to want you to use the random digits in the book, and they tell you only do it 5 times. So you're only going to have whatever how many notches you have here, go find your percentage and go do it. But in the other problem that you're going to do tonight, for sure. I'm going to want you to do it 30 or more times and then use that as a conclusion. The more you do it, the more you can trust this final answer. Yeah.
I forget where I heard this on the industry, but isn't 30 like the magic number?
It's a magic number. We're going to talk about why it's a magic number in statistics. It's a huge magic number. We'll talk about that later. Yeah.
For our homework, when you list in the different sections, do you want those in complete sentences, or do you want to like?
You know what? I think this is okay. I mean, look at one digit at a time. I like this. This should be a sentence. Okay. The repetition is just going to be numbers and what's going on. There's no sentence here, and then I want my conclusion in a nice big sentence. All right, new situation. Let's say I'm a basketball player and I'm a 72% free throw shooter. Okay, every time I shoot, there's a 72% chance I'm going to make it. I'm going to shoot 10 free throws, and I'm wondering, what are the chances? What's the probability that out of those 10 free throws, I'm going to make 8 or more free throws? All kinds of stuff going on there. Okay, I'm a 72% free throw shooter. I'm going to shoot 10 free throws, and I want to know, hey, what are the chances, if I'm a 72% free throw shooter, that I'm going to make 8 free throws, or 9 free throws, or 10 free throws out of those 10? What do you guys think? Is it likely? Is it impossible? Is it, what do you guys think? Fairly likely? More than 50%?
It would be a little under 50%.
Probably a little under. Okay, so we got some ideas on what it might be. How can we figure it out? Well, geez, I mean, I got to go find exactly a 72% free throw shooter, and then I've got to have him get up there and do this. I mean, it'd be pretty tough to do in real life, right? Let's shoot free throws in table B and see what happens. So let's go through the same process. A couple little tricky things here in this one. And remember, we're going to use table B. We're going to use table B to do this exact problem. Don't invent a new problem. Table B is going to do this exact situation. So, how are we going to assign digits? Yep.
One at a time.
Look at one digit at a time? How are you going to look at one digit at a time and get 72%? Right? It's got to mimic this exactly. Will one digit at a time get you to a 72% free throw shooter? You think 2?
Yeah.
Okay, so let's try your way. So we're going to look at 2 digits at a time. All right, how do you want to divvy up those digits?
Could you just stick with it even odd, or?
Even and odd. Will even and odd work? Will even and odd make you a 72% free throw shooter? Huh? Why'd you go 2 digits if you're just going to give me even and odd? Right, isn't even and odd going to make me a 50% free throw shooter?
Oh, right.
Oh, it's got to come up to 72%. That's why we're using 2 digits. What do you got?
So 1 through 72.
Okay, so 0, 1 to 72 is going to be a make, okay.
And 73 to 100. What's
To 100?
90.
If I'm looking for 100, I'm looking at 3 digits, right?
0 to 63.
So you're going to go 99 is a miss? That's not going to work. That's not going to exactly work. That's not going to be exactly 72%. That's going to be a little more than 72%. You want to fix it?
0, 0.
You don't even have to do that. You could do this, and that would be your representation of 100, right? Or the other way you were going to do it is what? 0, 0 to 71, and this would be 72 to 99. Either one of those is fine. You just have to make sure you have 72 numbers here and 28 numbers to look at here. Okay, so be careful with that 0, 0. The mistake you don't want to make is go 0, 0 to 72. Right? That's going to become 73%. So just be careful with that 0, 0. How about repeats? Repeats are fine, right? I mean, if I get 71, I get 71 again. I always want it to be 72% chance, right? So repeats are okay. Is there anything outside the range that I have to worry about? No. So we're okay. Stopping rule. Okay, when are we going to stop based on this particular problem that's been given to us? After 10 free throws. I'm going to shoot 10 free throws. All right, we're going to do one repetition. We're going to go shoot 10 free throws. And we're going to see how many we make. All right, so somebody help me out. Give me 2-digit numbers. Okay, go ahead, Jason.
19.
All right, 19. Oh, you start right at the beginning. All right. What's 19?
That is.
It's a make. Okay, so the next one.
22. That's me.
22 is a make. I'm using K for make because M and M, right? Okay.
39, 50, and 34.
Oh, hey, 2 digits at a time. 39 is a
Me.
good.
50.
Is a
Me.
yep.
34.
Is a
Me.
good.
57.
It- 57 is a make. Okay.
Yeah, 56. Me.
Hey, you skipped it. No, you
You skip 5.
You skipped the number, bro.
I skipped the number.
You skipped 0.
Skip to 0. It's 5.
0,
Okay, no problem. 34. Then what's next? 05.
Yeah.
Okay.
Then 75.
Ooh, 75 is a miss.
Miss.
Okay.
62.
Make
87.
is a miss.
13. Me.
Is a make, and I think that's 10. Okay, that's when we'd stop, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've done one repetition. A repetition in this problem is you got to shoot 10 free throws. And the last problem is you got to have so many babies until you get a boy. That was one repetition. Now we're going to go do this many times later. But right now, I want to develop a scoreboard that's going to help me just ultimately answer the question. So what, this is, like I said, I think this is the hardest part of this, is developing a scoreboard, taking this information we had, what, 8 makes, 2 misses. So what kind of a scoreboard do we make here, create, that will help me answer the question at the end?
Makes versus misses.
Okay, so you say makes and misses, right? So I have makes and misses here. What is that going to give me? Think about this for a second. So I do 8 and 2, and then 7 and 3, and then so I get my final answer is I got 500 makes and 492 misses.
You do great.
Does that help me answer the question that I need to answer here? So you understand what I'm saying here? You've got to focus on the question that they want us to answer, and I think you just said it. What do you want here?
You do greater than 80% or greater.
8 or greater, 7 or less. You know, you might write it like this, making 8 to 10, and then 0 to 7. Those are makes. That is a nice scoreboard for this problem, because that's what they were asking for. What are the chances of making 8 or more? So based on our first simulation, we got a number. Boom. Now, let's go do this 300 times. Okay? And then what the percentage that comes out of there is going to be really close to what the real percentage of that is. I mean, let's say we did it 30 times, so we had 7 up here, and then we had a whole bunch down here. We had 23 here. We did it 30 times. So the chances of making 7 out, or 8 or more out of 10 is whatever that is. Get that percentage, and then write up your conclusion. Based on our simulation, the probability, the chances of making 8 or more out of 10 is, and you can get the percentage. And again, the key thing I need you to remember is the more repetitions that you run, the more accurate your final prediction is going to be to what the real answer is. Okay, questions, comments?